All right, we're going to look at what I call the library of parent functions. And on Monday, I will give you a paper with, we'll graph all parent functions. But what we're going to do today is identify and graph linear, quadratic, cubic, square roots, reciprocal, piecewise functions. We're going to recognize the graphs of the parent graphs. First of all, a linear function is in the form f of x equals m of x plus b. That is slope-intercept form, where the graph is a line with a slope of m, and it looks like a line, has a y-intercept at the point 0b. The graph is increasing when its slope is greater than 0. And decreasing when its slope is less than 0. So example, write the linear function f of x, which has f of negative 2. It's defined as f of negative 2 equals 6 and f of 4 equals negative 9. Then graph the function. So what do we need to find first? The slope. What's the y values here? 6 and negative 9. 6 minus a negative 9. What are our x values? Here's x1. So negative 2 minus 4. This is 15 over negative 6. They're both divisible by 3. Get negative 5 halves. And now y equals mx plus b. Pick one of the points. I'm going to pick the first one. Y is 6. Slope is negative 5 over 2. X is negative 2 over 1 plus b. Twos will reduce, and a negative times a negative is positive, so that gives us 5 plus b, so b equals 1.
What just happened?
Negative 5 over 2 times negative 2 over 1. The 2's on the top and the bottom, they both are divisible by 2. So that negative times the negative left with the positive. And our equation is y equals negative 5 over 2x plus 1. Because we have to write the function, then graph it. So I have a y-intercept of 1, slope of negative 5. I could go up 5. I guess I can't because I'm going to run out of room. But I could go down 5, right 2. And you can see negative 2, 1, 2, 3, 4, 5, 6 is on the graph. 4, 9, we're kind of off. So what's our domain and range then here? All real numbers for which one? Both of them. I think writing the equations is a review. I believe you had to do that in an earlier lesson. But there are two special types of linear functions. The constant function f of x equals c. An example of this would be like y equals 2 is a horizontal line. Its domain is all reals, but its range is just y equals c, whatever that constant is. Y values don't ever change. The identity function, which is y equals x, has a slope of 1, y-intercept of 0, and its domain and range is all reals. Questions on a linear? Questions on linear functions? All right, let's look over at quadratics then. The quadratic, the parent graph is f of x equals x squared. This graph is a parabola with a vertex at, where is the vertex? The origin, 0, 0. What's its domain going to be? All real numbers. What's the range going to be? Y what? Y is greater than or equal to 0. Where does it have a line of symmetry at? Line of symmetry is a vertical line. So it's vertical. How about x equals 0? And this one happens to be an even function then. Remember, the line of symmetries will go through your vertex. Okay. This graph is decreasing. Well, let's graph it first to answer this one. So this is a parent function. This is one of those functions that I expect you to know how to graph from memory. And if we know the vertex is at 0, 0. What happens when I let x be 1? What's 1 squared? 1. So I have another point at 1, 1. What happens when x is negative 1? Y is still 1. What about 2? When x is 2, y is 4. And when x is negative 2, y is still 4. What we're going to end up doing is we're going to end up taking these parent graphs, we're going to end up shifting them and everything. So we'll talk more about them in depth in the next section, but you should know these 5 points on the parent graph of the y equals x squared from heart. Know that it has the vertex is at 0, 0. Then I go over 1, up 1 for the next 2 dots. Go back to the origin. Go over 2, both directions. Up 4 for the next 2. Okay? So now, when's it decreasing? It's decreasing on what interval? Say it again.
From -2 to 0.
Well, it's from -2, but it goes on forever. So it's from -infinity to 0. Remember, we don't include the infinity ever when we write interval notation. And when we're doing increasing and decreasing, we never include the other. So we just do 2 sets of parentheses. What's its increasing interval? Starts here, goes all the way, so from 0 to positive infinity. Questions there? It's an even function because it has symmetry with respect to what? The y-axis. All right, cubic function. Let's graph it first. Well, 0, 0. What happens when I let x be 1? 1. What happens when I let x be 2? 8. I'm off the chart somewhere up here. What about -1? -1 at -2, it's going to be -8 somewhere. So cubic graph looks like you're doing the freestyle in swimming. Right hand is up, left hand is back, ready to come around. So this graph has a point of inflection at 0, 0. We will talk about what points of inflections are here in a little bit. What's its domain? All reals. What's its range? All reals. This graph is an odd function because it has symmetry with respect to the origin. That means when the point 1, 1 is on it, so is the point -1, -1, 2, 8, -2, 8. That means the signs switch on both x and y. And that graph is increasing over its whole domain. Questions? Square root function. This graph begins at what point? 0, 0. When I let x be 1, what's y? What's the next point x value I can put in and get a whole number? 4. What's the square root of 4? 2. So what's its domain? X is greater than or equal to 0. What's its range? Y is greater than or equal to 0. And it's increasing on the interval from 0 to positive infinity. Questions there? My graph has really lost a lot. So this is a reciprocal we're going to do next. This is f of x equals 1 over x. Does yours have the xy coordinate here in it? No, you just got lost too. Alright, we'll just. It's 1 over x. Okay, can you plug in 0 for the x? No. Because you'll get a 0 in the denominator. Alright, what do you get when you plug in 1? 1. What happens when you plug in 1/2? What is 1 over 1/2? 2. And then 1/3 is smaller than 1/2, right? What happens when you plug that in? 3. What happens when I plug in 1 over 100? You get 100, 1 over 1,000. So between 0 and 1, this graph just keeps getting bigger and bigger and bigger until it gets so close to 0 we can't tell the difference. Okay? Now what happens when I plug in 2? You get what? 1/2, right? What happens when I plug in 3? 1/3. What happens when I plug in that 100? 1 over 100. When I plug in 1,000, I get 1 over 1,000. So this graph is going to approach the x-axis. What happens at -1? What's 1 over -1? -1. What happens to all these -1/2, -1/3? We're just going to keep getting actually smaller and smaller and smaller. Becomes like if I plug in a -1 over 100, I get a -100. Then what happens when I plug in -2? We get a -1/2. So this is going to approach the y-axis this way. So there's what that. Did you guys do this graph in algebra 2? So what's the domain of this function? All reals except what? Except x can't be 0. What's the range? All reals except y cannot be 0. This graph has a vertical asymptote, meaning it goes straight up and down where? At x equals 0. It has a horizontal asymptote at y equals 0. This graph is an odd function because it has symmetry with respect to the origin. You can see that here is 1, 1. Here's -1, -1. It's decreasing on what intervals? It's decreasing here. It's from -infinity to 0. And it's increasing. Is this increasing? No, this is also decreasing from 0 to +infinity. It's not increasing at all, it's decreasing all the way. We're decreasing, we're falling from here to here, and I'm falling from here to here. So it's not an increasing function at all, it's decreasing all the way. I tried to trick you into saying that this was increasing, because most of us believe that sometimes we have both in a function. And in this case, the whole function is decreasing. Alright, so how do we graph piecewise functions? This seems to be some of the hardest things that you guys seem to have trouble graphing. Let's look at this top function first. Negative 1/2 x minus 6. What does this graph look like? It's a line. Alright, we're only going to graph the part of the line that starts at negative 4 and gets smaller. So let's find f of negative 4. What do I get? And we're only looking at negative 1/2 x minus 6 for the moment. So I plug in that, I get negative 1/2. That's negative 4 minus 6, 2 minus 6, so I get negative 4. So negative 4, y value is negative 4. And why did I use a filled in dot? Because it's equal to, right here. Now this has a slope of negative 1/2. So I know a point on this line. Can I now graph another point using its slope? Yeah, I can go negative 1/2. So I can go up 1, left 2. Up 1, left 2. If you happen to go this way, do I want points to the right of negative 4? No, I want them to the left. I want all values less. So there's this one. What does the next part of this piecewise function graph look like? What is this a graph of? A line. Where's this line going to start? It's going to start at the next number bigger than negative 4. What is that next number bigger than negative 4? What about negative 3.5? What about negative 3.75? About negative 3.99999999. You know, we don't know what that very next number is. But we can plug in negative 4. So when I find f of negative 4, we get 1. So we know at negative 4, 1, it's next, that point is on the whole graph, the whole line, but we don't want to include it because it's not equal to, so we put an open circle. Do what?
Why is it on negative 2?
Because I just didn't count right. Negative 4, 1. There you go. And now this line has a slope of what? 1. So I go up 1 over 1, up 1 over 1. Connect my dots. Any questions here? Okay, the graphs studied in this lesson represent the most commonly used functions in algebra. You should be able to recognize these functions and be familiar with their basic characteristics. Questions there?